Okay, we're on day 3 of the review, and we're going to talk about other types of proofs. So remember, as we go through these other types of proofs, you don't have to freak out about them. I will not test you on them unless I give you a fill-in-the-blank type problem. I will not ask you to create one, but it's important that you understand them and understand how they're written. So the first thing we're going to do is go through a couple of more theorems. These are important to know before we get going on our fill-in-the-blank proofs. So if two angles are supplementary to the same angle or congruent, then they are congruent. Okay? So if angle 1 and angle 2 are supplementary, that means they equal 180 degrees. Then angle 2 and angle 3 are supplementary. Okay? So they also equal 180 degrees. Then that means that these two angles are congruent. Okay, the congruent complements theorem is if two angles are complementary to the same angle, then they are congruent. And it could be two congruent angles. So we've got angle 4 and angle 5 equal 90 degrees, and angle 6 and angle 5 equal 90 degrees. Therefore, angle 4 and angle 6 are congruent. The linear pair postulate, this is based on the fact that they are a linear pair. If two angles form a linear pair, then they are supplementary. Okay, so angle 1 and angle 2 form a linear pair, so therefore they are supplementary, and they equal 180. Remember, if you're going to use a linear pair in a proof, you have to first introduce them. So you would say angle 1 and angle 2 are a linear pair. And you would say the reason would be the definition of a linear pair. Once you've done that, then you can say angle 1 plus angle 2 equals 180 degrees by the linear pair postulate. Now, it might be that you have to prove that they're supplementary. So instead of saying this, you would say angle 1 and angle 2 are supplementary, and you would use this same reason. Okay, the vertical angle congruence theorem is that vertical angles are congruent. First, you have to establish that they are vertical angles. So you could say angle 1 and angle 3 are vertical angles. Okay? That would be the definition of vertical angles. Then you could say angle 1 is congruent, or the measure of angle 1 equals the measure of angle 3. So you could say it either way. You would say the vertical, actually would only say this one, the vertical angle congruence theorem. And then if you had to prove that they were equal, then you would go on to say the definition of congruent angles, because congruent angles have the same measure. So since this one is a congruence theorem, you could only say this, but then you could go one more step to prove that they're equal. Okay? All right, writing a flowchart proof. So this is where they draw these squares, and the statement that supports it goes down here. They give you these possible answers to put in here. Some of them are easy. For example, this one is obviously the given. And if I go from here to here, I can see that they subtracted AB from both sides. So I think D is my last statement. But then it gets a little scary, and I'm not quite sure. So take your time and look through this, maybe push pause, and I'll put up the answer in a minute. The answer. And there's the answer for your flow chart. So you would write your statements right underneath, like we did. Okay, in this case, we're going to write a flow chart proof. So they're telling us that angles 1 and angle 2 are supplementary, And then they're saying that angle 1 and angle 3, whoops, forgot the 3, equal 180. So they're supplementary. And they want you to prove that angle 2 is congruent to angle 3. So here's our flowchart proof. So we have angle 1 and angle 2 are supplementary. That was given. From there, they go to this follow-up statement. The measure of angle 1 plus the measure of angle 2 equals 180. That's the definition of supplementary angles. Angle 1 and angle 3 are supplementary. That's our second given. And that leads to this fact. Now know that flowchart proofs can be set up differently. We can put one given like this and the second given like this. Then the supporting piece of information could go here, like this. And then we're going to come together and put the rest of our information until we get to our proof. So flowchart proofs have a lot of different looks. So from here, now that we've proved this, we're going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. They used the transitive property. They said, since this equals 180 and 180 equals this, then this equals this. Okay? So you can do it back and forth like that. Then they said the measure of angle 2 equals the measure of angle 3 by the subtraction property. I subtracted the measure of angle 1 from both sides. Now, have I proved my statement? Not quite, because this is in an equality statement and it says the measure, and I need to change it to a congruency statement. So I just go the angle 2 is congruent to angle 3 by the definition of congruent angles. So just make sure you don't stop too soon and that you make sure that your proof matches what you were trying to prove in the first place. Okay, so this is an example of a paragraph proof, and I put the two-column proof here so that you can compare them. Take your time and think about it. They use a lot of transitional words in paragraph proofs to lead from one step to the other. So push pause and look at this and see if you can make sense of it. I'll be going over paragraph proofs in another section. All right, this is using angle relationships and mathematics, arithmetic, algebra to solve the problem. So we know that TPS and QPR are vertical angles. And so because of that fact that they are congruent, we can now set the two amounts equal to each other and use algebra to solve. So subtract 1, divide by 3, we get the answer. Now, be careful, because what are they asking for? Are they asking for x? We already know that this also equals 148, so we are solving for x. Okay? For this one, we're finding the value of w. These are vertical angles, so we know that they're equal. So we just set that up as 5w plus 3 equals 98. 5w equals 95. W equals 19. And of course, you might take a second to just plug it back in and make sure that it works. This is just an overview of the different proofs that they're giving the same proof in the three different ways, the proof of this, okay, in three different ways, so you can compare them. So if you want to look at this, pause and think about it. Okay, we're going to quickly, I want you to just pause and read this to familiarize yourself with parallel lines, skewed lines, and parallel planes. Okay, these are some of the concepts that you'll need also, and there are support for these two postulates. So the parallel postulate is if there is a line and a point not on that line, so we've got this, okay, then there is exactly one line through the point that is parallel to the given line. So then that's our parallel line. Okay? The perpendicular postulate says if there's a point that's not on a line, there is only one line that goes through there that is perpendicular. Okay, and we'll use this in other things that we do. So it's not a really important one, but it's one that will come in handy. Okay, so a transversal is a line that intersects two or more coplanar lines. The important thing I want you to notice about these concepts here are they are not parallel lines. So we are not trying to establish any properties here. We are just trying to identify what the angles are called. Okay, so angles that are on the same side of the transversal, this is the transversal, the same side on the same position on top of the angle are corresponding angles. The same could be true of this angle and this angle. They're in the same position on the lines, underneath the lines, on the same side of the transversal. Those are corresponding. Two angles are alternate interior angles if they're on opposite sides of the interior of the two lines, opposite sides of the transversal. Two lines are alternate exterior angles when they lie outside the two lines, we're outside them now, but on opposite sides of the transversal. And if we have two angles that are next to each other on the same side inside, those are consecutive interior angles. So now they're going to ask us to identify all pairs of the angles that are given. So if we were looking for corresponding angles, we could say 1 corresponds to 5, okay, 3 corresponds to 7, 2 corresponds to 6, and 4 corresponds to 8. So you can see there's 4 different sets of corresponding angles. The next one they want you to look for is alternate interior angles. So there's only 2 of those. We have 2 and 7 and 4 and 5. Okay, 4 and 5 are alternate interior angles. 2 and 7 are. Okay. Then we have your alternate exterior. That would be 3 and 6, alternate sides of the transversal, outside, and then 1 and 8. Okay? Consecutive interior would be 2 and 5 or 4 and 7. Okay, so classify the pair of numbered angles. So I can see that they are both on the same side of the transversal in the same position on the line. So therefore these are corresponding angles. These two are on opposite sides of the transversal on the outside of our two lines. So these are alternate exterior angles. 4 and 5 are on the opposite sides of the transversal on the inside. So these are alternate interior angles. Okay, so just make sure that you memorize those, and that is all for today.